precision vector in terms of i's and j's, and to come up with this, I'm going to make this my x and make this my y, and then solve for t and do a substitution. And you can see that's where the substitution comes from. Now keep in mind, they gave me this for a reason. So this dotted bit of the projectile is going to be this equation here. So over the page, where I'm asked to find, I'm told that the angle's 30, and it goes through this point here, 16,4. So I'd make y4, x16, x16, theta 30, solve for u, and I get 17.87. To the next question, I'm going to have a smooth join. I've got a smooth join at the point where it lands on the ramp. So, because it's a smooth join, it needs to be continuous. Therefore, the y value of the projectile and the y value of the ramp are equal to each other. So what I've done is I've made y equal to 4 and x equal to 16, but my unknowns are theta and u squared. And that's using this equation that they gave me in part A. The second thing is it has to be a smooth join. That is, the gradients are equal on the ramp, and the gradient on the ramp will be the tangent of the angle. And since it's a negative gradient, it's going to be negative tan of 10. And the gradient on the curve will be the derivative. And again, I'm going to use this equation that they gave me and take the derivative of this with respect to x. So now I have these two equations, one in terms of y's and two in terms of gradients equal to each other, that I need to solve. And I'm going to do that on the calculator. So I've entered my two equations. This is the y one. Now you'll notice that instead of typing u squared, I just typed y. And instead of typing u squared, I just typed y. The reason I did that was I didn't want to have the problem of solving for u being a square root. So I can solve for y, and that just gives me u squared. So I'm not going to put this into simultaneous equations. What I'm going to do is I'm going to take my first one, and I'm going to solve for y, which is really u squared. And then I'm going to take my second one, and I'm going to substitute out the y. Which will give me an expression for the gradient equals the gradient only in terms of x. And to that equation, I'm then going to, solve it, but because I've got theta, I'm going to put a stipulation that theta goes from 0 to 90. So my angle is just going to be in the first quadrant. And since I'm in degrees, that's why I use 90. And now I'm going to solve for x. Now, if on your calculator this doesn't work, that is, this takes forever and ever and ever to solve, then what I'd like to do is to graph it instead. So there's my answer, and I should have been in decimals. And there it is, 34.07, which is 34.07, which means to the nearest degree, that's 34 degrees. To find y, I know that y equals this, so I'm going to copy that. But remember, that's u squared. Paste, given this answer for x, gives me an answer. Then I'm going to take the square root of all of this. Which gives me 16.37, the second part of the answer. Now, what if your calculator didn't do this solving. So what I'd like to do is on my graphing window, I'd like to edit, clear all, OK. Thinking about my window, my angles are going to go up to 90 degrees. My gradients need to go down to negative. So I'm going to, where's the equation that I'm looking for? I'm trying to solve this equation here. So I'm going to drag the left-hand side into my graphing window. And then I'm going to drag the right-hand side into my graphing window. And analysis GSOL, that intersection point should be 34.017, and there it is, much quicker to find. Okay, so that's how that works. Moving further into the question, we were told that we have this expression for acceleration. So I need to replace my acceleration with a good substitution. And since I've got velocity and distance, I'm going to use v to v dx, then separation of variables, adding my c, my constant, then making at rest. So therefore, when I started, the velocity is 0. That gives me that expression. And then over the page, I need to interpret this. This is what my velocity against distance graph looks like. And I finish at 20, and then I can use that with the rule on the previous page to work out that the distance is 400 on 9. So I know the B is at 400 on 9. Now, I need to increase speed to a point, then I need to decelerate at a gradient of -9. So I need to know what is the velocity at that point. If a is the distance that I start decelerating, then this distance here is 400 on 9 minus a. So I'd like to find out what is the velocity at 400 on 9 minus a. So I sub that into this rule, and that gives me this. And I'm going to use this because I know that during this period of deceleration, a is constant because it's always -9. And subbing into this where eventually I'm going to stop, so u is 0. The velocity will be the velocity at the point which is 400 on 9 minus a. To acceleration is -9, and a is the distance that I'm looking for. Put in the calculator and solve for a, therefore 16.4.